All right, this is the unit for lesson 4 set section, because I told you could go ahead and skip the go section, and I believe it starts on your page 36. Again, somehow your packet got misnumbered or misprinted from the original that we sent. All right, so in question 8, how does solving an inequality compare to solving an equation? And you could answer this in your own words, however you wish. But honestly, remember the steps are the same. There's something important that happens when we multiply or divide by a negative. And if you are taking my advice that I strongly encourage you to take, we really solve an inequality by turning it into an equation, solving the equation, and then testing like our solution on a number line. Okay, so I will model that in this video. There are multiple other ways that we could solve an inequality though. So in number 9, we're asked to solve for x and then indicate if that value that we're given is part of the solution set. So what I am strongly proposing we do is that we could rewrite first this equation that will tell us where 2x minus 9 is equal to 3. Because if I know for what values of x I'm equal, like if I know the solutions for where x, the value of x that would make this equal to 3, I could easily test on either side of that to see which inputs would be creating a true inequality here. So I'm going to also just out to the side, I like to write my inequality symbol so I don't forget about it. Okay, now using the properties of equality, I know the addition property tells me I can add the same number to both sides. So on the left, I get 2x, and on the right, I get 12. And then the division property tells me I could divide both sides by the same number, so I get x equals 6. But remember, x does not equal 6 because we're not actually solving the equation. So what I would do is I would go to my number line, I'd put the number 6 on there, and I'm going to use an open circle because this is a less than symbol. So x is never equal to 6. And then I'm just going to plug in a value to the left or to the right of 6 to test. So this interval, like I'm going to highlight this for just a second. Everything over here, this represents the interval from -infinity to 6. So I could input any number I want. So like 0 seems like the easiest choice. And then on the right-hand side of 6, I could input any number that's greater than 6. So from 6 to infinity. So you might choose 7 or you might choose 10, right? Because it's easier to multiply 2 times 10 than, I don't know, 2 times 7, although I hope you know 2 times 7. Okay, so on the left-hand side, if I plug in the number 0, sometimes I like to just write it down here. If I plug that in, 2 times 0 minus 9 is 0 minus 9, -9, and that is less than 3. If I plug in, let's say, a 10 on the other side, I would get 20 minus 9, which is not less than 3. So when I shade my number line, I want to, again, start with my open circle, but then I want to shade in the direction of that statement being true. And then when I go, so like my final answer here, I could write it 2 ways. I could write the inequality that corresponds with this. So all of the values that I'm considering for x must be less than 6. Or I could use interval notation. This is the interval from -infinity to +6. So it's not a sideways 8, that's an infinity. So is the value x equals 6 part of the solution set? And the answer is no, because this was not a less than or equal to. Like had this been a less than or equal to symbol, then yes. Additionally, in interval notation, that's why we're using parentheses, not brackets. All right, and number 10, same thing. In fact, I'm going to scooch over. So I'm going to take my inequality. I'm going to start by rewriting it as an equation. Now I'm going to use the properties of equality. So I could subtract 25 because I want to undo subtraction or addition before I undo multiplication or division. That's the subtraction property of equality when we do that. 13 minus 25, I believe that is negative 12. Then I could divide both sides by 4. Right, when I do that, I get x equals negative 3. But I'm not done because x was never negative 3. Remember, our symbol here is the greater than symbol. So I want to find values of x that make the left side greater than 13. So I know it's going to have to be on one side or the other of negative 3, since plugging a negative 3 in for x and evaluating makes that equal to 13. So let's pick a number on, well, you know what? It's probably easier to test the right side because 0 is to the right of negative 3 on the number line. So if I plug in a 0, 4 times 0 is 0. 0 plus 25 is greater than 13. So this side works. Just to illustrate, if I plug in, say, like a negative 4 here, I would get negative 16 plus 25, which is not greater than 13. So again, I want an open circle because I'm not equal to 13. And I want to shade in the positive direction. And so I could write my inequality that x must be greater than negative 3. And I could write this as an interval from negative 3 to positive infinity. So is the value negative 5 part of the solution set? No, negative 5 is to the left of negative 3. It's not on that interval. Okay, I am not going to do the video for 11 and 12. I do want you to work those out. If you have questions, we could check those in class. So I might highlight these and I could say check in class. But we're doing the same thing that we were up there. Actually, how about this? I'll work one out because there is one difference that I didn't notice till just now. Let's look at number 11 real quickly. What I did just now notice, what made me change my mind ever so slightly, is that this is not the less than symbol, it's the less than or equal to, and that is going to make this just a little bit different. So again, first, let's figure out the values of x that make 6x minus 4 equal to negative 28. So we just change this to an equation. Solve by using, well, first the addition property of equality. Then I could use the division property to undo that multiplication of 6. I get x equals negative 4. So now the first step that's different is when I make my number line, I actually want a closed circle there because x can be negative 4 since 6x minus 4 can equal negative 28. And then I want to again test to find the interval, so either from negative infinity to negative 4 or negative 4 to positive infinity, that contains values that will make 6x minus 4 less than negative 28. So let's say I plug in a negative 5. Well, 6 times negative 5 would be negative 30. If I subtract 4 from that, I get negative 34, which is indeed less than 28. And if I plug in a number to the right of negative 4 just to test, like let's say I plug in a 0, 6 times 0 is 0 minus 4, I would get negative 4, which is not less than negative 28. So my solution here, I should have done this in a different color. I'm just going to shade in this direction. Again, I'm going to answer that by saying x is less than or equal to negative 4. And I could write this as an interval. So from negative infinity to negative 4. Remember, we use a bracket here because of the or equal to. Is the value negative 10 part of the solution set? Why, yes, it is. Negative 10 is on that interval. All right, we're doing very much the same thing in this last set. I figured maybe we could work like one problem. Okay, we're doing a lot of the same in this last part. It's important though, like we need this practice. So let's just do a really simple, maybe like 2. How about 2? I'm talking to the video like you're responding or something. Let's look at number 16 because this is one that I think students could try to do in their head because it looks so simple and it would be really easy to make a critical mistake here. So this is one where you could just divide both sides by negative 10 and you would want to change the sign of the inequality if you do that. I like my tried and true method. I like to change this to an equation because then I don't make mistakes with the inequality symbol. Divide both sides by -10 using that division property. We get x is -15, but then I want to test. So remember, this is the less than sign on my number line. I want to go to -15, or sorry, I said less than, that's the greater than sign. And I want to know, like, where can I plug in values that will make -10 times x, like, greater than 150. So I could test any point on this number line. So how about I try 0 first? 0 is my favorite point to test. 0 is to the right of -15. So if I do -10 times 0, I get 0, and that number is not greater than 150. So let's double check. Let's pick a negative number to the left of -15. How about -16? So -10 times -16, that's that's positive 160. Negative times a negative, that is greater than 150. So my solution is I'm going to put an open circle on the -15 because I don't have an or equal to, and I will shade in this direction. And if I were writing my solution as an inequality, I would say that x is less than -15. So if you did it a different way where you divide, remember when you divide or multiply by a negative, you have to swap the direction of the inequality symbol. All right. I'm actually going to skip down to these Go questions, and we'll just do these in one video since we're kind of cruising here. At the bottom, and again, let me be clear, I do expect y'all to do more of the inequalities. I just thought I'd help you with a few of them. At the Go section at the bottom, evaluate each of the functions as indicated. So I notice that I'm inputting x values into all of these. So like y is equal to g of x, meaning that g of x is an output, but the thing that I put in to g, I put in my input. So 3 and -5 are inputs. So in function notation, which is why I love it, if I have g of 3, I take my function g of x, and I literally replace each x with the 3 by substitution. 7 times 3 is 21. 21 minus 8 is what, like 14 maybe? Nope, 13 maybe. My brain is way too tired to do math right now. Actually, I think is it 13? Oh my goodness. Well, I hope it's 13 because I just can't. It's almost 1 in the morning as I'm making this video. All right, if we try D, we're going to do the same thing, but with a -5. So 7 times -5 minus 8. 7 times -5 is -35. When I subtract 8 from that, that's really like I'm adding 2 negatives. I could think of that as like -35 plus -8. So I should get -43. All right, so in question 21, you are pretty much doing the same thing there, except our function's called h, but otherwise we're doing the same thing. So I'll let you finish that one. And then let's look at these last 3. So again, we're solving literal equations here, and these are all things that you're gonna see in geometry or in science or in real life. Number 22, D equals R times T. That's a physics formula. Distance equals rate times time. And we're asked to solve for R. So remember, with literal equations, that really means isolate R. So I want to undo what's being done to R. So D divided by T equals R. Also, how many times have we done that exact equation? I feel like a lot. All right, 23. This looks like the area of a triangle. So if I'm going to solve for H, I'm going to isolate H. This one's I've got to do in a couple steps. Well, I could first multiply by 2 on both sides because that would eliminate the division of 2 or undo the division of 2 on the right hand side. Then lastly, I have BH. I could divide both sides by B to get H by itself. Oops. So when I do that, I have 2a divided by b yields h. Lastly, we have a conversion formula that would convert degrees Celsius into Fahrenheit. Y'all, this one's really helpful, especially in science. So if we solve this for C, it would help us input Fahrenheit and convert to Celsius. Okay, so I want to undo the addition or subtraction first. So I'm going to subtract 32 from both sides. So my left-hand side is now F minus 32. And my right-hand side is 9/5 C. And then you could do this in one step. You know, I'm a weirdo and I like to do it in two. To undo 9/5, you could multiply by 5/9 on both sides. I find students sometimes think that's confusing. So what if we just do it in two steps, like multiply everything by 5, and we've eliminated the fraction. So I now have 5 times F minus 32 equals 9C. You can distribute that 5 if you want. I'm just going to let it hang out there in factored form. And then lastly, I could divide both sides by 9. So Celsius is 5 times our temperature in degrees Fahrenheit minus 32, like that quantity. So we would subtract first, then divide by 9. All right, that's it for the set and the go for this one.